Destination Earth is an ambitious initiative by European Commission that aims to build digital twins of the Earth to support decision-making on climate change. In TerraDT, we aim to enhance Destination Earth to provide more reliable projections of future climate, as well as more relevant information for users in different sectors about climate change impacts. TerraDT is needed because the core climate models of Destination Earth currently describe some key components of the Earth system only in a limited way. In TerraDT, we also develop a basis for modular infrastructure that makes it easier to add new components to these core models.
And here in TerraDT, we want to add other components which are important in the Earth system. So there we, for example, sea ice, inland ice, or more features in the land surfaces. And for that, we need interfaces to the existing models already.
We love to be the glue in the end for this project, because there are already components out there, but in the end we have to combine them. And what else can we do better than just gluing all these components together?
And we would like to help the different scientific communities, the different objectives from the science, to be able to use the different infrastructure in a homogeneous way, that those workflows can be used to different systems and that deliver the scientific outcome of the project.
At CSC, we host LUMI supercomputer, which is extensively used for the climate simulations of the TerraDT project. One of the main advantage of LUMI supercomputer is that it has like 2000 plus GPU nodes, which are very useful for the computational efficiency of the climate model simulations.
I'm also working at Barcelona Supercomputing Center when we are hosting Magnus 5, one of the EuroSPC machines in Europe. And also our main focus is to ensure that the TerraDT and other ambitious projects as Destination Earth exploit in an efficient way from the computational perspective all these scientific projects that are focusing on the climate variability and prediction. From BSc and BSc, we not only provide support for the use of the EuroSPC machines, but also to create a common infrastructure for both projects, Destination Earth and TerraDT.
There are many projects that have been before and in the future also ongoing at the same time with TerraDT that explore similar topics, impact areas and methodologies that we can learn from and also collaborate with in order to avoid overlap between the projects. For example, the Nordic Cryosphere digital twin has been doing models for sea ice, and we have a strong sea ice component.
Specifically, we are doing the impact modeling of sea ice.
And we have very good connection with the user of TerraDT products.
There are links between land use, land cover, and climate that really are important if we want to be able to capture, for example, how you can have changes in droughts or changes in local effects really due to changes in land cover, things like deforestation, or even things like changing forests.
We will be setting up a user advisory group with representatives of all the main stakeholder groups that we are targeting, and they will be using our models, our impact models, and give us feedback how to improve them and make them at the very end potentially scalable and usable by DestinE and other relevant initiatives in the European domain.